Welcome to another exercise in Workbook Statistics. This time I'm going to focus on an exercise talking or using the hypergeometric distribution. Let's have a look at the exercise. One of a university's departments offers this semester 48 lectures. Of these lectures, a student wants to take 4. Of all lectures offered, 4 have a focus on statistics. Well, so much for the information. Our first task then, assuming the student select his lectures at random. What is in this case the probability that he will not take any statistics lecture? Second, what is the probability that the student takes at least one statistics lecture? And finally, the chance of passing a statistics lecture is 81%. In all other lectures, it is on average 93%. What is the overall rate of failing in an exam? Well, let's work through the 3 parts step by step, starting with the first one. But before we do this, let's clear why we actually have to use hypergeometric distribution here. Well, if the student visits or attends 4 seminars or lectures, he usually does not attend one of these lectures twice, 3 times. He attends each lecture at most once. Meaning what we have here is a selection without replacement. Once he selected one of the lectures, he will not select the same lecture again. That's a clear indicator that we have to use the hypergeometric distribution. Well, with this in mind, let's jump into it and start with part A. In part A, we're looking for that none of the lectures are on statistics. So we have a small k of 0. And from the exercise text, we also get a total of 48 lectures, 4 with a focus on statistics, and the student selects 4 lectures, so we have a sample size of 4. With this, we have all the information required for using the probability function of the hypergeometric distribution. So we can just insert the values. Here we have large K over small k. So this represents how many lectures in our sample should be on statistics and how many could be on statistics. On the other hand, the second part, that's large n minus large k over small n minus small k. This represents how many lectures in our sample should not be on statistics and how many could not be on statistics. So 4 statistics lectures, 44 non-statistic lectures. And we divide this by 48 over 4, so that's large N over small n. Putting this into the calculator gives us a result of 69.77%, so almost 70% that none of his randomly selected lectures will be on statistics. Well, that was already part 1. So let's turn to the second part, to part B. Here we're looking for the probability that at least one of the lectures will be on statistics. Well, if we go with this, we would have to take one of the lectures, 2, 3, or 4. So we would have to calculate 4 probabilities. If, however, we use the counter probability, so 1 minus, and then we go with the opposite of this, the logical opposite of larger or equal to would be smaller than. Well, x being smaller than 1, there's actually only one integer smaller than 1, and that's 0. So this can be simplified to 1 minus probability of x being 0. Incidentally, we already calculated this value in part A, so we could simply copy-paste the result from A. However, well, we could also use the probability function. But as I said here, in this case, we already have this. We have this from part A. So we can simply copy paste this here and then get our final result respectively. And well, that was already the second part, this here showing us the probability that at least one lecture will be on statistics of the selective ones. So in the third and final part, in part C, what we're looking for is the probability that he will pass, or that someone will pass a lecture. That's not so much related to the hypergeometric distribution anymore, but it uses the same information we have in the exercise. What we're actually looking for here, well, probability that he will pass, we're looking more or less for something like a total probability. We know the chances of taking or getting a statistics lecture are 4 in 48. The chances of picking a non-statistics lecture are 44 in 48. And we know the chances of passing a statistics or a non-statistics lecture. So using the theorem for total probability, that's what we're going to do in the calculation part. We're simply going to multiply these two, those two, and add this up, giving us then as a result 92%. So the chance of passing a random lecture are just 92%. So the statistics lectures pulling the overall slightly down, but only slightly because there's only 4 of the statistics lectures. Well, that's about it on this exercise. I hope you enjoyed it. I say goodbye and see you next time.